Welcome back to the Advanced Arduino Basic project, and today we will learning about smart parking system. And here is the agenda: overview, components, principle, schematic, procedure of smart parking system. And next is the overview. We will program the Arduino to achieve the automation of a smart parking system. The system will automatically control the entry gate and track space availability using ultrasonic distance sensors and a servo motor. For this project, these are the required components, that is Arduino Uno, ultrasonic sensor, micro servo, LCD, breadboard and jumper wires. And next is the principle. The system operates on the principle of ultrasonic distance detection and sequential state logic. It uses sound waves to detect a vehicle presence and direction, triggering a servo-driven gate only when parking slots are available, while updating the occupancy count in real time on an LCD. So, sensing, validation, actuation, tracking. So what is sensing? So the project contains these 4 steps. So sensing is nothing but the Arduino continuously calculates the distance of objects using the time of flight of ultrasonic pulses. So if a car is detected at the entry within the distance threshold, the code verifies if slot is greater than 0. If space is available, the servo rotates to open the barrier. If not, it remains locked and displays a full warning. Using flags to track the car's movement across 2 sensors, the system ensures the slot count is only updated once the car has completely cleared the gate. That's all about the principle. And next is the schematic. Here you can see servo, LCD, Arduino Uno and ultrasonic sensors. And next is the procedure. Step 1. So here we are using 2 ultrasonic sensor and 1 servo motor, then LCD display and microcontroller, Arduino Uno. And step 2 is the program. So here you can see it starts by communicating with your 16x2 screen using the I2C address of 0627. This is the setup initialization, and here we defining the pin numbers of ultrasonic sensor. So const int is a data type and trigger pin echo pin of the ultrasonic sensor, entry sensor and exit sensor. And here we consider distance threshold as 130. And here we having 2 slots. So we using 2 ultrasonic sensor. You can use n number of sensor and you can make n number of slots by using n number of sensor. Int flag 1 equals to 0 and flag 2 equals to 0. And this is the setup function. So here we used serial begin. This is for serial monitor, and LCD begin for initialize the LCD. And this is permanent black light on, means LCD set black light, backlight is 1, sorry, not black light, backlight. And next is the ultrasonic sensor setup. So it will tells the Arduino whether entry trip pin is output or input. Similarly, entry echo pin and exit trip pin and exit echo pin. And here you can see it attaches to pin 4, that is servo, and sets to gate to 100 degree, which is the closed position. So it starts with the default of 2 parking spots available, and here initial display message is smart parking. And here you can see the measuring distance. The function measure distance is the eyes of the project. It sends out a sound wave using the trip pin. It waits for the echo to bounce back. It calculates the distance using the speed of sound. So speed of light or speed of sound is this one, 0.034, and convert to cm by 2. So if an object is within 130 centimeter, that is distance threshold, the system considers a car present. And next is the loop function. So a car enters, that is the entry logic. The system checks if the entry sensor sees a car, and if slot is greater than 0, if it is true means it sets flag 1 equals to 1, moves the servo to 0 degree, that is open gate, and subtract 1 from the slot count. Here you can see slot minus minus, slot equals to slot minus 1, like that. So if full means if slot is 0, it doesn't open the gate. Instead it displays sorry, parking full on the LCD for 3 seconds. A car leaves exit logic. The system checks the exit sensor. So if car is detected, it sets flag 2 equals to 1. If the car is exiting, it opens the gate and adds 1 back to the slot count. That means slot equals to slot plus 1. So slot value is incremented here, and closing the gate. So this is the reset mechanism. The code waits for a handshake between the sensors. When a car is halfway through, both sensors will eventually be triggered. So flag equals to 1 and flag 2 equals to 1. The moment the system sees both flags are active, it assumes the car has passed through. It moves the servo back to 100 degree, that is close gate, and reset the flags to 0 for the next car. And it prints welcome. If it will update the display welcome, then it prints the value of slots. That's all about the code. And the flag 1 and flag 2, here you can see the flag 1 and flag 2 are the two variables. These are crucial. They act as a memory for the Arduino. So without flags, the code would here you can see the code would subtract a slot every single time it ran the loop. As long as a car was standing in front of the sensor, it will happen. So by using flags, the code says I already counted this car once, don't count it again until the car has completely passed it. Okay, that's all about the code. Now we need to do this using the Tinkercad simulator. So what are the required components? Arduino Uno, ultrasonic sensor, servo motor and LCD display. So here we using I2C LCD. So the required components are servo motor, rotate it, then LCD, search here, LCD I2C. Yeah, here we using this one, LCD, yeah, this one, and next we need ultrasonic sensor. So here we using 4-pin ultrasonic sensor. Yeah, so that's all about the components. placing is done. Yeah, now we need to do the connections. So I'll move little up. So this trig pin should be connected to the pin number 5. So this is pin number 5. And it should be connected, echo pin should be connected to the pin number 6. So here we having pin number 6. Change the color if you want. Then ultrasonic sensor 2, it should be connected to pin number 7. I'll change the color. And one more pin, I am connecting it to the pin number 8. And I am changing this color to blue. Yeah, now we need to connect this signal pin. So here I am connecting this pin to pin number 4. So this is pin number 4. I am changing this color to pink. Yeah, now this connection is over. Now left is power pin connection. So here I am connecting this to positive rail. So I am changing this to red. And here we also have red. So I am connecting directly power pin connection, and here also there, and here. And it should be connected to the Arduino 5 volt pin, that is the power connection. And here we need to short this. Power connection is over. Now we need to connect the ground pins. So here the ground pin should be connected to the negative rail. One second. So it should be connected to the negative rail of the breadboard. So this is negative rail. And here now we need to connect this to here, and it should be connected to the ground of the Arduino Uno. Ground connection is done, and here all connection is done except this, right? Negative rail, and it should be connected to the positive rail. And this SD pin should be connected. Here I am connecting this to A4, and SL pin I am connecting this to A5, analog pins. So I am changing this to, and this color to pink color. That's all about the connection. And next is the coding part. So here So now start simulation. So here you can see server is rotating, but LCD is not displaying, right? Here you need to change 0x27. In code also you just see we mentioned 0x27. Yeah, now it should work. Smart parking, server is rotating. Here you can see welcome slot left 1. Now change the distance. Now slot left 0. So sorry, parking full. So the distance threshold we already set as 130 centimeter, right? See here, based on the slot left value it is rotating servo. Now parking full. Here slot left 1. Just vary the distance, then you will see both conditions. See, slot left 0, parking full. So that's all about the smart parking system. For more project, please watch the upcoming videos. Thank you all.